afternoon, 8th period.
Good afternoon.
Oh, that was weak.
Good afternoon.
Try it again. Good afternoon, 8th period.
Good afternoon,
Esperanza.
That was really cute. You know what? I can't complain. That was adorable. Awesome. Thank you very much. As promised yesterday, today is going to be an algebra connection. We're going to be talking about solving equations that have this x squared thing in it. That means they're quadratic. And we're going to be using some of the theorems that you have seen in 11.1 and modeling how to use those in context of the questions that you have to practice on page 185. So let's get right on to it. Let's start with a circle. Please draw a circle on your paper. Don't make it too big. Don't make it too small. Make it just right. Okay, here we go. And I need you please to draw a tangent segment. Please remember that a tangent is just a line that touches the circle in one spot and one spot only. The spot at which it touches the circle is called the point of tangency. So we'll be connecting the point of tangency to the center with a radius. Whenever this happens, we form a perpendicular intersection between the radius and the tangent line. Go ahead and connect the center of the circle to the end of your little tangent segment there, and we'll have created our figure. I need two numbers, smaller than 10, but both positive. Go.
9.
8.
9 and 2 is what I heard first. Thank you very much. There we go. Please label your figure this way. These are the kinds of questions that you will see on page 185, and it's going to say solve for x or something similar. And this is all the information it gives you. And you're stuck going, what in the world is it going on about? Right? It's like, what? Great question. No, we are not going to be using trigonometry on this one. But I like that you ask that because it's a right triangle, right? But with trig, we need two sides and an angle. That's not the 90-degree angle. I don't have that. I have three sides.
Sorry.
We're not going to use trigonometry because we have three sides, not two sides and an angle that's not the 90. What formula do we have that uses three sides for a right triangle? Yeah, the Pythagorean Theorem. What does it say? What's Pythagorean?
A squared plus B squared equals C squared.
Yeah, lovely. And a race to see who said it first. I like it.
I said it first.
I love it. You thought it first? Good. I got the psychic memo. I heard you. I can read minds. Not really.
Oh, I was about to say what the same.
This one is A. Okay, honestly, it doesn't matter which one I pick to be A and B. Okay, I just like the little one to be A. This one will be B. The one that is important for you to always make sure you pick properly is C. Yeah, because it's the hypotenuse, the one across from the right angle. Now, is it 2x squared? Ooh, great question. You'll see in just a moment. Hang on to that thought.
Or is it x squared plus 2?
Ooh, all right. Hang on to those. You're going to see in just a moment. So what was A? I color-coded it. X, thank you. And what was B?
9.
9.
I said 9.
And what was C?
2.
The entire length of C.
2x.
Not just 2.
3. 2x.
Okay. And we've got our first points of we're scratching our heads and not sure where to go. Is it 2x or 2 plus x?
It's
2 plus x.
2 plus x. Because it's cutting off. And then I have to add that part of the 2.
All right. What's happening here between the 2 and the x?
They're going to play.
They're multiplying. And here?
They're adding.
Now look at the figure. How do you get the full length of the green line given the part that's 2 and the part that's x?
You have to add.
You have to add them. So it is?
Add.
2 plus x.
2 plus x. X.
That one. I was trying to get rid of it and it wasn't working. So you said 2 plus x squared?
Yeah.
You are exactly right. There it is. Lovely work. Okay, I'm going to pull out my yellow pen so that I can put my little step divider bars so we don't get lost. All right, now this looks like a bit of a mess. Yeah? Because we've got parentheses and exponents and craziness. Yeah, so let's apply those exponents and see if we can't make it look a little neater. This says x squared, which is the same as x squared. Did you hear the pause?
Yeah.
The pause showed you where that grouping was. This says 9 squared.
Yeah.
What is 9
81.
squared?
81.
How did you get 81?
9 times 9.
Because I learned in 3rd grade my times tables.
You learned your times tables and it was 9 times 9.
Yes,
That
ma'am.
exponent, that squared, tells you take the thing in the parentheses and multiply it to itself 2 times.
Yeah.
All right, so what would this be?
2 squared plus x squared.
Okay.
I mean 4 plus x squared.
4 plus x squared. So you're telling me that it's going to turn into this.
Yes, ma'am.
Okay. The question I have for you is, how did you get that?
Because I just squared 2 and I also squared x.
Okay, so what he did was he took our original and he applied the square to both things inside, which seems fairly reasonable because it seems like that's what's happening with the 9. However, we have to apply the definition exactly. This says multiply the thing to itself twice. If, when we do this multiplication, we get x plus, 4 plus x squared, then you're exactly right, and the shortcut you just found will work every single time. But if it doesn't, you can't use that shortcut. Okay? How many remember the FOIL method from Algebra 1 last year?
Oh, I kind of remember.
You-
Is it the one where you have to crisscross and all that stuff with that? So you have to make a square?
Yeah, there's a lot of different methods.
Yeah.
The FOIL method in a nutshell is an abbreviation to help you remember to multiply everything in this group times everything in this other group, and it gives you a way to track which ones you've done so you don't get lost.
Oh, yeah. So
You can use the crisscross method, you can use the squares method, you can draw little arcs between them. I like to use dots. Honestly, it doesn't matter. You do the way that's comfortable for you.
oh, you can also do arrows, right?
Or you can do arrows. You just have to make sure that you have multiplied the first 2 terms, the outer 2 terms, the inner 2 terms, and the last 2 terms of those 2 groups. If you have done that and added them all together, you've done it properly.
Right.
I'm going to show you the dots that I use, okay? You
I guess.
inner. Inner. Thank you for asking. Inner. All right. So we're going to deal with the right-hand side. We'll deal with the left later. So it says first. So I'm going to multiply the first 2 terms of each of those groups. That's 4. So far, so good. Looks like what you gave me. Outer. Outer and outer.
2x.
And I'm going to add it. Then it says the inner.
X squared, isn't it?
No, it's still 2 times x.
Oh, okay.
I'm going to add it. And then it says the last. Last and last. This is x squared because I have x times x. This looks a little different than what you gave me. So the shortcut that you gave me doesn't work. Okay? All right. Algebra 2 will take a little more time to remind you of that, of the reasons why it didn't work.
Just combine like terms.
Yep, time to combine some like terms. Not doing anything special or fancy here. Now we need to solve this thing.
Yes, ma'am.
regardless of the kind of equation you are given, the funky symbols that you see there, how big or small the numbers are, the goal for solving is always the same. Whatever variable you are wanting to solve for, get it by itself on one side of the equation and put the rest of the party on the other side. That's all you do. It's just that easy. The steps how you get there, you learn as you go. We'll give them to you, right? But that's the goal. Keep that goal in mind. 1x by himself, one side of the equation, all the rest of the junk on the other side. All right. So, do you want him on the left or on the right?
Left.
All right, on the left. So that means let's get rid of this x squared thing first, just because it seems to be the most confusing, all right? He's just a term. He's being added. He's just a term. I don't know the rest of the song, so I can't make anything up. Sorry. So we're going to subtract 1x squared from the right. We're going to subtract 1x squared from the left. It cancels itself out on the right, and it cancels itself out on the left. Hey, look at that. Yeah, it worked out. This one was a nice one. We did not have to do very much. And now it's an equation that is very familiar. You guys are really getting really good at these kinds of equations. You really are, because you talk me through it like twice a week at least. Subtract 4, divide by 4.
Yeah.
Do it.
Oh, you want us to subtract from? Oh, it's 67.
67?
Yeah.
No.
Isn't 7 plus 4 11?
It is
So then what do you do? I mean 77. Stupid. Like that.
77. Okay, and then divide that by 4 and you're going to get, I don't know, some decimal fraction thing that. You're going to get that. I don't know what that is. Well, I don't really care what that is. You got the steps, and that's what's important. All right, thumbs up. This felt pretty comfortable. We're okay. Thumbs sideways. It was a little confusing, but once we got rid of that x squared, I was just fine.
Yeah, it was easy.
Thumbs down, your way lost. Vote now.
I already voted. I said it was easy.
That was easy. All right. Cool. I don't have any thumbs down. I'm pretty happy. All right. Let's talk about the next kind of item that you are going to see on page 185. For this figure, please draw yourself a circle. Put a dot, a point somewhere outside of the circle, and then connect the circle to the dot with a tangent. Again, a tangent is a line that only touches a circle at one spot, the point of tangency. Okay? My circle's not the most beautifully round circle in the world, but he gets the job. So you end up with something that looks like this, an ice cream cone that's fallen out of someone's hand and about to land on the floor.
I want ice cream, please.
You're welcome. I've been wanting ice cream too, because I've been using that example all day. I know, I'm sad. Or Jack in the Box's head, you know.
Now I want Jack in the Box.
Yeah, right? The ultimate bacon. Okay, I'll stop. And then you're going to be given something like this. With the directions, solve for x.
Why does Jack in the Box get ever so complicated?
Because I don't know.
Because he's Jack in the Box.
Because he's Jack in the Box. No one knows.
I wonder why you needed that.
Because it's Jack and he has a box.
And he's inside of it. It's nothing to do with a closet, okay? We won't go there. Anyway, moving on. So this is all we're given.
Jack in the Box.
This is all we're given. And we have to figure out what x is. But wait. In video 11.1, we had a theorem that said when we had this ice cream cone Jack in the Box head looking setup, we had two tangents that connect to a common point somewhere outside the circle, that those segments between that common point and each of those points of tangency, where the tangents hit the circle, thems are congruent. We got a theorem that tells us that.
The Hungry Man Theorem.
Sure, go ahead and call it that. Hungry man theorem, because it looks like the ice cream cone or Jack in the Box's head, and now it makes us hungry. If things are congruent, then their measures are?
Equal.
Yeah, equal. Say it all together. If two things are congruent, then their measures are?
Equal.
Equal. So don't think, write that. This measure is equal to this measure. Okay. I'm going to break for halftime here. I'm going to give you guys 15 seconds to get up, wiggle, shout, make some motions, because the next part is going to go on and I'm going to need your entire focus for the next section. So you got 15-second halftime right now. Go.
Ah! I shouted. You say we can shout, miss.
Sure. And get up and move around, talk. You got 10 seconds
I want
left.
to rest my legs, miss.
Whoa. No flash photography in my face. Holy cow.
Magic. Bro, we hit the line flat.
Yeah, I
was like,
All right. All right. Thank you very much.
You're welcome, miss.
Let's get into solving these things. This equation type is a quadratic equation. It's a quadratic equation because the variable that we're interested in
Is the square?
has the square. And for no other reason. That's why it's called a
Quadratic.
called a quadratic.
It curves, right? It's like a U.
Yeah, it's kind of like a U. There are 3 ways to solve quadratic equations. They are, in no particular order, factoring, the quadratic formula, and linearly. We've done linearly before. It's when you solve it exactly like you would any other equation you've done before, like this one up here on the top part of your notes. But toward the end, you make use of the square root symbol thing to get rid of the squared. Okay? We've done it a lot when we did the Pythagorean Theorem and we were trying to solve for one of the missing leg links. So you know how to do it linearly. We just didn't call it that at the time. But that's what we were doing. So I'm going to focus on showing you today these 2 methods, factoring and the quadratic formula. Both of these, regardless of which one you use, require that the quadratic equation be equal to 0. If it's not equal to 0, these don't work. This one's not equal to 0. So we got to do whatever we need to do to make it equal 0. And that doesn't mean just take one side and set, like, draw 0 and be done with it. I'm going to remove all the stuff on one side of the equation. And whatever I do to it to remove it, I need to do to the other side of the equation. When I have completed this step, I will have a quadratic equation equal to 0.
X squared plus 2, X squared minus 1.
Now we can set it up for solving. If you're at the bottom of your paper, I urge you to go ahead and flip your paper and start afresh, because there's going to be a lot to write. I'm going to make it fit on what I have left. All right, let's start with factoring. Some things to know before we start factoring. There's a reason why I'm picking it first. It is not hard to do. It is easy to mess up. There's a lot of steps. There's a lot of little tiny steps. All of them are easy to do. We're just going to be adding some stuff. We're going to be multiplying some stuff. We're going to be thinking about what things multiply together to give us stuff. None of that is hard. But if you miss one of them, or you do it in the wrong order, you make a big giant disaster area, okay? So I'm going to very, very strongly urge and encourage you to use this left-hand side to keep track of the order in which we do things. That said, I do not need you to be experts at factoring today, or tomorrow, or next week, or even this year. I want to introduce to you a method to factor everything that you encounter, or to decide that you can't. Because next year in Algebra 2, you will be required, go ahead, you okay? You will be required, that sounds like fun. Next year in Algebra 2, you will be required to do at least 2 to 3 weeks of factoring, and you will need to be experts at it. So if I can make you uncomfortable with it now, then, thank you. Then when you get to it next year, you won't be as, oh my God, what the factor?
With the anglicized.
Okay? All right, here we go. Factoring starts with the quadratic formula, quadratic equation equal to 0. Here's the first thing I need you to do.
Yeah, ma'am.
I need you to take this number, just the number, not the variable, which we will call A, and multiply it to this number, just the number, not the variable,
It's negative 2, miss.
which we will call C, and I want you to please multiply those together.
It's negative 2.
Please write out your multiplications.
Negative 2.
Negative 2. The next step. Please list all the numbers, the pairs of numbers, that you multiply together to give you negative 2.
Negative 2. That's it. That is it.
Okay? The next step. Please add them together.
Oh, that's 1 and 1. I mean, negative 1 and 1. Or 1 and negative 1.
The next step. Find the pair that when you've added them gives you this number here in the middle, which we will call B.
Negative 2 plus 1.
The second factor pair gives you the negative 1 for B. The next step. You will take this middle term right here and you will replace it with 2 terms. And the 2 terms you will be replacing it with have coefficients, the numbers with the variables, that are these numbers right here. I will write everything that doesn't change in black and the stuff that you are altering in red. Please take a moment to absorb what just happened.
You changed out the negative x and the negative 1. Oh no, just the negative x.
All right, you see it? Again, not a hard step to do. Next step. I need you to make groups using parentheses and put a plus sign between them. You must put a plus sign between them because otherwise the next thing doesn't work. It's not a plus sign because something in here was a plus sign. It's a plus sign because it must be. Now, take 2 terms and put them into each group. You're sorting things. I'm going to zoom in really tight, and I'm going to write really, really small.
Yes, ma'am.
Okay? There we go. Here it is. The next thing that you have to do at this point is you have to find what numbers you multiply together to give you each of the terms in each group. This first term, 2x squared, can be gotten by multiplying 2 times x times x. You can get that number by multiplying 2 times x times x.
There you go.
Thank you. To be gotten. Yeah, it sounded weird. Thank you. I didn't realize it till you mentioned it. I can get negative 2x, because you have to think about the sign as well,
Negative 2 times x.
by doing negative 2 times x. But I can also do it by multiplying negative 1 times 2 times x. And so which one is the best one to use?
I like negative 2 times x.
I do too because it's smaller. However, look at the other term.
It's too big, man.
The other term doesn't have a negative 2 in it. It just has a positive 2 in it.
Yeah.
So since I will be looking for things that are the same and I want to find as much that is the same as possible, I'm going to go with the one that has a positive 2 as a factor. Okay? So far so good?
Yes, ma'am.
Nothing challenging.
No.
Okay. We're going to highlight or circle the factors that each has in common. That's the 2 and the x. That's my greatest common factor, and I'm going to write it right out here and put parentheses. And in the parentheses, I'm going to put the things that I didn't highlight in the order that they show up in, including whatever signs they had. Boom, done. The plus sign comes down. And I'm going to do it again with this group. I know what you might be thinking at this point. Miss, we're trying to solve this thing and you've made a big giant mess and now there's like way more x's than we had the first time and I'm going a little crazy. I know. It's okay. We have to make a bit of a mess before it cleans up. Look at what we created right here. Look at these two things right here. Aren't those exactly the same? And aren't they being multiplied to their buddy? We have just created another common factor. So just like we did in this step to this step, right here, right above it, I'm going to do it again. Here's my common factor. And then in parentheses, I'm going to write what was left over that I did not highlight. This is factored completely. This is what they will spend about 2 weeks on in Algebra 2 trying to get you to do. You can go back and watch this video anytime you want when you get there.
Yes, ma'am.
All right. It's not solved, though. The whole point in doing this was to solve the equation, get an x all by itself, and we haven't done it. In order to solve it from here, which we are really close to, it'll be like 2 steps left, we need to make use of something called the zero product property. Now, if you don't remember this name, it's okay. But what this thing basically tells you is that if you've got a bunch of stuff multiplying together that equals 0, something in that big string of stuff had to have been 0. And if you've got something with variables in there, this is a way to help you to figure out what the value of x has to be in order to make one of those things in there 0. So if I look at the first factor, what number does x have to be so that that thing is 0?
1. Wow.
You're right.
Oh my God.
Let's look at the second one. What number does x have to be so that this equals to 0? Not as easy to see right off the top of your head, so we're going to apply a little bit of algebra to it. Subtract 1 from both sides, divide everything by 2, bam! This thing has 2 answers. It's okay. It's supposed to have 2 answers. In fact, in Algebra 2, there's a bunch of study where we look at things that have way more than 2 answers. And some of those answers aren't even real numbers.
What?
They're imaginary numbers. Someone just made them up.
Like flat?
No, not like phlegm. Yuck.
That's between, no, okay, yeah. I guess we got you.
Yeah. That all you'll deal with in Algebra 2. For us right now here in geometry, if you are looking at this kind of thing, you've got two things that can happen. Okay? If you were calculating, I don't know, how many boxes of brick you needed to build your house or your football stadium or whatever it is that you're designing, and you got these two answers, does it make sense to have -1/2 boxes of brick? Yeah, no, it's weird, right? So you can take this answer and throw it away. It doesn't make sense. Okay? All right. Let's zoom out a moment. We have one last one to look at. It is going to be way, way shorter than the factoring, which is why I started there. Let's look at how to solve it when we're using the quadratic formula. Like the factoring, the quadratic formula requires, it requires you to use the quadratic equation equal to 0. The good thing about the quadratic equation is it is always going to work for you. You don't want to factor it? No problem. Quadratic formula gives you the answer. It can't be factored whatsoever? No problem. Quadratic formula will give you the answer. The bad thing about the quadratic formula is I don't think it's listed for you on your reference charts, and so this thing you're going to have to just memorize. So I'm going to teach it to you the way my mommy taught it to me, that has had me memorize it for the past 20-something years.
Was your mommy a teacher too?
No, my mommy was not a teacher. My mommy was just my teacher.
Oh, okay. Were you homeschooled?
No, but anytime I got home and I needed to learn something, she would teach me.
Aww.
Even if it meant that she had to take out her shoe and, no, I'm just kidding.
What?
Oh, jeez.
John Glass, no. That only makes sense here in the valley. John Glasses. All right, let me teach you the quadratic formula the way my mommy taught me. Are you ready? I have to clear my throat. Here we go. You ready? Here we go. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. That's how my mommy taught me the quadratic formula. You don't have to memorize it that way, but I urge you to find some manner in which to get it memorized, because I don't think it's on our reference charts. I've heard it sung to Adele's Rollin' in the Deep. I will try to find that song and post it to our playlist so that you can sing it and you can see it. And if you like it, go for it. All right. One last thing to say. Hang on. Shh. Thank you. One last thing to say about the quadratic formula, and then we are done. And I know this one has rang long, which is why I gave you your half time. Okay. Do you see the symbol right here?
Yes.
Yeah.
The plus or the minus?
Yes.
The only confusing thing, the delicate thing, gentlemen, wait, gentlemen. The only delicate thing about the quadratic formula is that this symbol means that you must do it twice. You must substitute into the quadratic formula where you take that as a plus sign. And then you must do it again, but take it as a minus sign. If you did not do it twice, once plus and once minus, you didn't give me the whole story. And you have just cost yourself possible solutions to whatever problem you were trying to solve. The A, B, and C come from the exact same place as the A, B, and C is from the factoring. A is this number, just the number, not the variable. B is this number, just the number, not the variable. C is this number, just the number, not the variable. Okay, you're telling me there's no variable there. There isn't now, but there might be in Algebra 2. Substitute, plug in the numbers, crunch it, done.